This video is for September 16th, September 19th. We're looking at graphing secant, cosecant. Now, this is the second or third time I tried to upload this video to YouTube. It hasn't worked for me, so I'm covering these up, and I'll uncover as we go through it and explain what's happening. I'm not going to graph it all again and try to keep the video short here. But we're going to graph secant to start, and we're going to graph secant using cosine because cosine and secant are reciprocals of each other. So if we can graph cosine, if we can find the values for cosine, then maybe we can do secant because secant is the reciprocal of cosine. All right. Now, when we're talking about the x values, what's happening is we're going to go ahead and look on our unit circle. So if you're looking at a unit circle, 0, it might be good to have this out. And anytime you want to pause it, make sure you understand what's happening. That might be good. But on our unit circle, 0 is here. And we're going to use 0 because, and we have 0, 1, I already checked it off. Yeah, because I already did it. But 0, the cosine value here is 1. Cosine 0 is 1, which means cosine 0 equals 1, which means secant, the reciprocal, would also be 1. So our order pair here is 0, 1. Now, around the unit circle, we want to find easy values for that would be easy to take the reciprocal of. So here, the next one would be pi over 6, if you're looking at your unit circle. But cosine at pi over 6 is square root of 3 over 2. And if we take the reciprocal of square root of 3 over 2, it would be 2 over square root of 3. That's not going to be easy to plot, so we're going to skip that one. By similar logic, pi over 4, which is the next radian measure above the x-axis, the value, cosine value, is square root of 2 over 2, so we're going to skip that one as well. Similar logic to pi over 6. But pi over 3, the radian measure, or the cosine value at pi over 3 is 1/2. So we can do this. So if our x value is pi over 3, then cosine of pi over 3 is 1/2, which means secant, we take the reciprocal of 1/2, would be 2. Excuse me. So our order pair would be pi over 3, comma 2. Similar thing, we could keep going around. Pi over 2 we'll use. Now here, pi over 2, cosine is pi over 2 is 0. If we take the reciprocal of 0, secant of pi over 2 would be undefined. We can't take the reciprocal of 0. So we have an undefined line there. 2 pi over 3, similar thing. Cosine 2 pi over 3 would be negative 1/2, which means that secant would be negative 2. Pi negative 1, 3 pi over 2, and undefined. So these are our ordered pairs. Now, I already graphed it, and I'm going to explain. Instead of actually going through graphing it, I'm going to explain. Here's the graph for secant. Now, I usually go piece by piece, but again, this is like the third time I'm trying to upload this, so I'm just going to go ahead and use the graph. 0, undefined here at pi over 2. The reason we have a dotted line like this is, if you think about slope, we have 0, like with mx plus b. If a line is straight horizontal, like my pen is right now, that means the slope is 0. If it tilts this way, that means the slope is positive. If it tilts this way, slope is negative. If it's straight up and down, then our function or our slope is undefined. So what's happening at pi over 2 is the function takes no value at pi over 2. So we draw a dotted line to signify that the function will not either touch or cross pi over 2. Now, so we talked about that one. Let's talk about 0, 1 and pi negative 1. 0, 1 is here, pi negative 1 right there. We can also do any value that is 1, plot a point there. So here, negative 2 pi 1, because the reciprocal of 1 is 1. Cosine of 2 pi over here is 1. The reciprocal of 1 is 1. I should mention, this blue dotted line is the parent function for cosine. So cosine is this blue dotted line. Okay. Similar for -1, if cosine's value is -1, the reciprocal of -1 is -1. So that's why these points exist. And then essentially what we see is pi over 3. Pi over 3 would be here, 2. 2 pi, we could also say negative pi over 3, 2. 2 pi over 3, 2. This one will be a 2. And so in between our dotted lines, our undefined lines, we have this U shape. This U shape happening. I would suggest plotting those points, and then we'll see this U shape. Ooh, excuse me. So, how is this function behaving? What's happening? Well, here we have cosine. Okay. In class, we said undefined lines occur where it crosses the x-axis. So at 3 pi over 2, pi over 2, negative pi over 2, negative 3 pi over 2. And the reason we have undefined lines there is because cosine's value at those points is 0. Cosine is 0 at each point there. The reciprocal of 0 is undefined. So we draw a dotted line, and that's why we have dotted lines at where it touches the x-axis. And then what we also noticed is we have points at each of the peaks, the maximum points of cosine. We have dots there. We have dots at the minimum points of cosine. And if it's at a maximum, then the U shape going from that point is an upwards U, or regular U. Same thing here, upwards U. If it's in a minimum, it's a downwards U, like this. And so this is our function for secant. We'll go through it again for cosecant. This is video 1. Go to video 2 to talk about what makes this function unique. Domain, range, amplitude, or amplitude period. What are those values? What are our ranges? Come back for video 2 to figure that out.